Two talks are invited, the first and the third. The second is instead a regular contribution. So I think we can start with the first speaker, which is Lucas Cordeiro. I will, for those who don't know him, I will tell a bit of bio, but probably many of you already have heard of him. Lucas Cordeiro is from Brazil, right? And currently working in the UK, especially in the Department of Computer Science at the University of Manchester. He's expert of security, and in fact, he leads the System and Software Security Research Group. And he is also the director of the ARM Center of Excellence at the University of Manchester. And he leads the Trusted Digital System Cluster, still at the same university. He's affiliated with the Formal Methods Group at the University of Manchester and to the postgraduate programs in electrical engineering and informatics at the Federal University of Amazonas, which clearly you know it is in Brazil. The talk is Exploiting the SAT Revolution for Automated Software Verification, report from an industrial case study. I think we are already ready to display.
Can I play? Can I start the video?
Yes, sure. I think you can start.
Okay.
So my talk today, I'm going to discuss about the past, present, and future of software model checking based on SAT and SMT solving. So I'm a reader in the Department of Computer Science. My research lies in the field of program verification, program synthesis, software testing, security, and cyber physical system. So the research that I'm going to present today, it's a collaboration with my postdocs, PhD students, and also collaborators from other continents, especially in Brazil and South Africa. So I'm going to cover here two research questions. So the first research question that I want to answer for this presentation is, give a computer program and a specification. So that specification can be, for example, I want to check for memory saved errors, right? Like user after free, buffer overflow, and so on. Then I want to answer the question whether we can automatically verify that the program performs as specified. So we know that the program verification is undecidable due to the unbounded memory usage. And then this talk, so I'm going to give some idea of how we handle decidability in program verification. And then the second research question stems from the fact that, well, a large part of my research, so I develop verification, software verification testing tools for industrial languages, including, for example, C, C++, Java. And then in particular, C and C++, we have a lot of legacy code. And then you know that C and C++ are unsafe programming languages. And then I want to answer the question here. So can you leverage program analysis and synthesis to discover more software vulnerabilities than existing state-of-the-art approaches? So these are the two research questions that I want to answer. So then the objective of my talk is to quickly give you an overview, right? I don't focus here on a specific paper. Actually, I will try to give you an overview of the past, present, and future of what I have done in terms of software model checking based on SAT and SMT solving. So I'm going to cover some topics like, okay, to help us to deal with decidability. So we analyze bounded program runs, right? So we bound the number of loop interactions, the recursion, the number of context switch that I have among the threads so that you can achieve decidability. And then you do this via a technique that's called bounded model checking. Nowadays, we can see such solvers that they can handle formulas with millions of variables. So in the 90s, we had the breakthrough with the CDCL solvers, the conflict-driven closed learning. And then in particular with the such solvers GRASP and ZSHAF. So nowadays you can actually solve formulas with millions of constraints. And then you can also exploit SMT, satisfiability model theories, where those sophisticated SMT solvers are built on top of such solvers. and they allow us to provide a better encodings using word-level theories. In particular, we can use a decidable fragment of first-order theories. And lastly, so we can also infer some properties, right? Some invariants from the program, and also exploit mathematical induction so that we can go further with the state space exploration and then help us to verify more programs than plain BMC. So here's just a quick overview of user SAT solving as enabling technology. So in the 90s, as I mentioned, we had a breakthrough in the field. So we started seeing SAT solvers like GRASP and ZSHAF implement techniques like unit propagation, conflict clause, and no chronological backtracking. And then we started seeing SAT solvers handling millions of constraints, and then allowing us to liberate several applications, like, for example, concolic testing, program analysis, equivalence checking, also using program synthesis. And annually, so we have a SAT competition, right? And then in the last SAT competition, so we started seeing also parallel SAT solvers that they consistently outperform the sequential SAT solvers. So then you can use multi-core architectures, clusters, so that you can solve even larger formulas, and then allow us to go deeper into the state space exploration. So then talking about how we handle decidability, right, and work on model checking of software. So we model a program as a state transition system, right? So it can be a C, C++, Java. And then that state transition system, so you have a set of initial states, you have a set of states, you have a set of transitions that's going to tell me how I can go from one state to another. I have also an evaluation function that's going to tell me if a property holds in a particular state. And then here, the notion of state, I have the value of my program counter that can tell me exactly where I am during the symbolic execution of the program, and the program variables that include the local and global variables. Then you derive a control flow graph. And then when you derive the control flow graph, we also automatically add safety properties as extra nodes to the control flow graph. And what are the safety properties? For example, I can check the bounds of an array. I can check use of the free. I can check division by zero, arithmetic overflow. Or if I'm dealing with multi-threaded programs, I can also instrument the CFG to look for data races. And then we unfold the program up to the given bounds. And then here we exploit several techniques from the compiler domain. In particular, you do constant propagation. So you detect when a variable is initialized with a constant. So you propagate that throughout the program. Forward substitution. So when you symbolically execute the program, when you get an expression that's repeated during the symbolic execution, so we store this in a cache. And then if that expression appears again, so just retrieve from the cache. And also, we detect unreachable code. So given a property that I want to check in my program, right? So then I can identify the basic blocks, for example, that do not contribute to that, to check that given property in my program. So then we build an SSA, this static single assign form. So here we have the variables that we assign a value exactly once to those variables. So then from the SSA, we build two sets of formulas at the constraints that they represent here, the assignments that I have to the program, and also the properties that I want to check. Then I can select the SMT solver, right, that I want to use, and also the theories. So here I can use two theories. One, that's the theory of bit vectors. Then I can precisely model the semantics of the program. Or I can use also integer and real arithmetic. So then I can model the program variables, use the integer and real from the mathematical domain, right? And then I pass this formula, the conjunction between the constraints and properties, and look that I negate here the property because I'm particularly interested in finding property violations. So I have written this fragment of code here in Visual Studio. So let me switch here to Visual Studio, and then I want just to give an idea of how the technique works. So when you want to verify program, the programs, they use libraries, and then you have to implementation with the code of the library, or we create an operational model of that library. And what's that operational model? The operational model, we are gonna introduce pre and post conditions, and also some code to simulate the behavior of the library. And then I want to check whether my program correctly uses the library. So I have the assumption that the library is correct, and then I want to detect bugs from my program when I interact with that library. So then just to give here an idea of how it works. So then we have here in this example of the password, we have the C function gets. We know that's an unsafe program, unsafe function. But then I here just give an idea of how to write the operational model, right? So here I have a no-deterministic unsigned integer number that, well, I don't know how many characters the user can provide. And then once I get that no-deterministic unsigned integer, so then I iterate in a loop, and then I'm gonna also store no-deterministic character to the position of my buffer, okay? So that's one way that I can use here to write that operational model for the gets. And then if you call here our verification tool for this particular example, right? And then I use here an incremental BMC. Incremental, just dash incremental BMC. So then we're gonna build the transition system, then we derive the control flow graph to unfold the program, and then we get here a trace, right? So it has found a property violation, and then in the trace, it tells me, look, if the user provides here 7 characters, and then here we have the character for each position, so you get array bounds violated, right? So then I can go back here to the original code, and then, well, we know that the safe version of gets is fgets, where you give the pointer to buff, the number of characters, and then I'm gonna collect those characters from the standard input. So then, in our verification framework, we have an operational model already implemented for most of the functions in the C library. So that one is implemented internally. So I just call here again the software verifier in this particular example, and then it tells me that's verification successful with respect to memory safety issues, right? So in a nutshell, that's how the technique works. We have evaluated here initially this approach with some embedded system applications. So in particular, I have collected benchmarks here from PowerStone, from automotive control, real-time SNU, which includes signal processing, Fourier transform, JPEG encoding, and they also So in total here we have 34 applications, we call as verification tasks. We set a timeout of 900 seconds and a memory of 15 gigabytes. So here, our verification engine, we support 2 types of arithmetic, fixed point and floating point arithmetic. So here we have enabled the floating point engine. And then you can see here that in our approach that's implemented in SPMC, so we got here to the second position, that evaluation, compared to what the state of the other tools, right? We have 2LS here, which implements k-induction and invariant inference. And then you notice that, well, the BMC technique, it struggles when you verify programs that contain loops, and then with large bounds for those loops, or even with unbounded loops. Right, and then just to give an idea here of how the BMC technique deals with those loops. So consider here this code fragment. Then I have the question, so does this program terminate? So if you look at the loop, right, so then we have here that constraint that y is smaller than 1000, and there also no deterministic variable here. And then you can see, well, that loop is going to, well, we are going to unfold that loop 1000 times before actually we check that assertion. So yeah, this program is going to terminate, right? So again, I wrote this example here in Visual Studio, right? And then, let me move here. And then I'm gonna run here in the background. So I call this example as contractor. And then you can see, well, that the verification engine is going to unfold 1000 times that loop, right? And then it's going to create a huge logical formula to be checked by the solver. I'll go back to that example later here in my presentation. So one way that you deal with that part of the state space reduction, the research that we're currently doing in our research group, is to use interval methods via contractors. So how it works? We have here a simple program, right, that we have the variable x and y. And then we have also the constraints for x and y, x greater or equal than 20 and smaller or equal than 30, and y smaller or equal than 30. And then we use static analysis. In particular, in our verification framework, we build a dependency graph, and then we can find maximum and minimum values for each variable that I have in the program. And then the second step, what to do, you convert the problem into a CSP, the constraint satisfaction problem, where you have the variables, domains, and constraints. And then from the SSP, we apply the contractors from the interval methods. And then in contractors, we have essentially two operations, that the forward and backward operation. The forward, I'm gonna analyze the intervals that I start the entry point until the accession, and the backward, I analyze from the accession to the entry point. And then we're gonna apply the contractors to SSP, so we can see here the state space region, right? And then after apply the contractor tells me, look, well, from y, when you consider from 0 to 20, the property holds, but I don't know from 20 to 30, right? And then that is represented by the orange area. And then we feed this information here back to the program via assume, right? So that the model checker can explore that region that we don't know if it's going, if the property is going to hold or not. So going back here to our example, you can see that it's still running, right? And then we're gonna cancel here. I did the homework to compute those intervals using contractors. And then if I go back here, right? So then we can see that you still unroll the loop 1,000 times. And then you build the logical formula that's going to be given to the solver. But look, now it was much faster, right? With that state space reduction. So you could verify in less than 10 seconds, this example. And then you can say, Lucas, can you do better and not unfold 1,000 times? Yes, we can do better. So we could use an induction, approved by induction procedure, right? So I'm not going to explain here how we do induction of programs, right? So I would need more 20 minutes to talk about that. But then we can see that, well, we just need to unfold 47 times that loop with those invariants in order to prove the correctness of this program. So going back to my presentation, so here's some experimental evaluation, right, of those techniques. Here we can see our BMC engine, right, without using the contractors. We can see that we time out in some case. And then when you use contractors, we can substantially reduce verification time. And they also prune the search space exploration. As you can see here, in some case, you can also prune but look, you have a CSP step before, so it takes time, right? Well, but if you take a look here, that column that tells us the time, it varies from microseconds, milliseconds, and then the largest one that I have is here for this example that it took 12 seconds to compute the intervals, right? And then the BMC engine verified that program in less than 1 second, while the original BMC timeout. And then if I use just the contractors, so I could determine whether an assertion holds or not, just in 4 cases here. And here comparison from ASI, which is a state-of-the-art verification tool that's based on abstract interpretation, that builds abstract domains based on intervals, octagons, convex polyhedra. And then so from ASI was able to determine whether the assertion holds just in 3 cases. Lucas, have you evaluated this in a large set of benchmarks? Yes, we have an international competition on software verification that's held as part of ETAPS at TACAS. So here's an important category that's called reach safety. So then we check the reachability of a bad state. Then you can see here that our verification platform that was represented here with SPMC. So we got here very close to the 3rd place. That's the green one, as you can see in the graph, right? So we achieved the 4th place here. And then the SVCon benchmarks, they include verification tasks with the Linux kernel, Windows device drivers, several open source applications. And then you have also companies that fund the competition. In particular, one company that funds the competition is the Amazon Web Service. So Amazon, they have an automated reasoning group. So they do a formal verification of programs as well. So they have contributed to a subcategory that's called AWS. And then that essentially we have real code that they verify at AWS. And then here is our verification framework that got the second place here. So the first one was Symbiotic, which does some sort of a better program slice than us. But even so it achieved good results here. And then what BMC is really good is to find bugs, right? So, and then there's a category that we have the following problem. So given the program and the specification, find me a test case that covers the bug, that finds the bug, right? So we have participated here with a tool that's called Fuse BMC, right? And then as you can see here, so it was by far the best verification method to find bugs in programs. There is one that you can use as reference, that's CLI. That's a software testing tool that's quite well used in industry as well. So then you can see that, well, the technique is quite competitive. So in terms of achievement, that work started my PhD in Southampton from 2008 to 2000. Distinguished Paper Award at ICSI. Then since 2012, I always participate in those international competitions on software verification testing with my research team. We have accumulated 28 awards during those years. And then our strength here is in bug finding and cover error. We have also Intel that deploys ESBMC in production as one of its verification engine, in particular to verify firmware in C. And in the past, we had also collaboration with Nokia. And then Nokia used ESBMC to verify telecommunication software written in C++, and they also found real vulnerabilities that were fixed by the developers. So in terms of conclusions, so as SAT SMT-based model check is a competitive method, as you have seen compared to other state-of-the-art techniques. We handle a variety of safety properties, including memory, reachability, concurrency. We support several verification strategies that include incremental verification, key induction, termination, invariant inference, and also the verification platform that we developed in Manchester. So it's also part of some EPSRC products that we're running right now. In particular, we have one that's Scotch, where we are developing formal analysis tools for capability hardware. So here's the website of ESBMC. So you can see the documentation, publications that we have. And then I have also added here the link to access the GitHub. So the source code is available in GitHub. We use a partial license. And yeah, that's all. So thank you very much. And I'll be happy to answer a question.
Oh, great. Thank you, Lucas. We usually thank the speaker, but we virtually thank the speaker. I have some questions, but first I would like to know if anyone wants to start asking. We have time for questions. Okay, in the meantime, I will do the first question. How all of these relates to standards? I mean, did you also try to apply it in standards for safety critical system, and in which phase or how?
Yeah, so far, Andrea, our main collaborator right now is Intel, and then to verify firmware at Intel, so they essentially check for memory safety, which includes pointer, dereference, arithmetic overflow, buffer overflow, right? And then that industry, to the best of my knowledge, so they don't have something like the avionics, right? I think avionics, they have some defined standard that you have to follow. So we had contact with somebody from Airbus that they are keen to try to use what you do in terms of software verification for avionics software. But in order to apply in that domain, yeah, you have to follow what you just mentioned. So you have to follow a standard protocol, right? Some rules that they have. But we have not advanced so far to verify avionics software. We have been more in the firmware industry, and in the past also in the telecommunication industry. But just to check for memory safety errors.
Okay, thanks. I have, since you mentioned in Intel, I always had the impression that approaches based on model checking are welcomed, but also very difficult for especially people in the company to apply on their own, let's say. So what is your experience? Did you have someone expert at Intel, or were you doing the work and proposing results?
Yeah. Let me tell how it works, the collaboration with Intel, because I think it's quite interesting. Actually, Intel, they have a very strong formal verification engineers. And then we collaborate with two teams, one in the United States and another one in Israel. And each team in Israel, so we have three formal verification engineers that are senior. And at the US, so you have one senior formal verification engineer. And then Intel fully funds one PhD student in Manchester to work on this collaboration, right? So then we have meetings every week with those two teams of senior formal verification engineers, where they apply, right, the tool that we develop. And then we have two situations here. We have situation that well, when they find bugs, right, that they want confirmation that the bugs are real, and sometimes they also find problems, right, in our tool. And initially, to get those people to use the tool that to develop, so first of all, they have strong background in formal verification, so they understand what's model checking, what's a linear time temporal logic, right? So they have all the formal background. And then we had initially some short trainings to tell how the tool works, what are the capabilities of the tool, right? And then those weeks that we meet together, they always come with very good ideas of how, for example, how you could do things better, right? How you could exploit some existing verification algorithm in our platform. And then it's like an exchange of knowledge, because we learn from them and they also learn from us, right? Mm-hmm. But I think the crucial point that it works quite well with Intel is that they have people that they understand formal verification. But as you pointed out, so if you try to use this technology with someone that does not have the background in formal methods, yeah, that's tricky. That's tricky. That's not easy. And then that was our experience with Nokia, right? So when you collaborate with Nokia, so we couldn't get people at Nokia to use our tools because it seems to be a bit complicated. And then we had an NDA in place, a no disclosure agreement. And our team in the university used to get the code from Nokia and then apply those techniques in that code. And then used to report for the developers, then the developers check, confirm if it's a bug, right? And that's our two different types of collaboration. One that we have people expert in industry or formal verification, the other one that we don't have people that are expert. And then in this case, so our team used to conduct the application of the tool to real code base.
Okay.
Yeah.
Thanks. Yes. Are there other questions? Otherwise, I can do my third question, but I want to spend the last minutes if there are questions from the audience.
Andrew, I have a question.
Okay. Yes, speak, Jerry.
Okay. Lucas, first off, thank you for your participation in the sessions, and congratulations for your tool and very great results.
Thank you.
And are you going to have your tool integrated with some other development tools like Eclipse or something like that?
Yeah, so in the past, Rogério, we had in Eclipse our tool integrated, but right now, no, we just run as a command line tool. I'm planning now to actually integrate that verification framework in Microsoft Visual Studio. So I'm going to get one team member to do that integration with Microsoft Visual Studio. But right now, how, for example, people at Intel, they use ESPMC, so they have actually the build system, because our tools connect to Clang. the Clang compiler, okay? And then, for example, instead of calling Clang, they just replace the build script that they have, and then they call ESPMC to do the formal verification. And then they do this integrated with the build system, right? So every time that a developer pushes code, so they go to the build system and then they run the verification tool instead of the Clang compiler, right? In order to verify the entire code base. But we have plans now to integrate this also in Microsoft Visual Studio so that other developers can also try to use it in a integrated development environment.
Okay, understood.
Yeah.
Great. Thank you, Lucas.
Thank you, Rogério.
There is time for the last quick question. I will do it. Could you tell a bit more on the most common type of security flaws that you find? I mean, the most common problems that you identify.
Well, yeah, in terms of firmware, I would say that buffer overflow and arithmetic overflow. So there are the common types of bugs. And then in firmware, they don't use dynamic memory allocation, right? But if you take a look at the common weaknesses enumeration website that they list the common vulnerabilities in open source applications, in addition to buffer overflow, the top 10 security vulnerabilities use it after free, right? So with Intel, they have found the case of buffer overflow and arithmetic overflow, right? But once you go to the domain that you have to allocate memory dynamically, which is not the case for firmware, right? So you have also seen in open source application a lot of user after free vulnerabilities.
Okay, thanks. Clear. Last call for questions. 3, 2, 1. Okay. At this point, we thank again the speaker.
Thank you.
Okay. It's not the same effect as in presence, but it's like it was a strong applause. Thank you, Lucas.
Thank you very much.
For your talk. And we can also move to the second speaker, which is Andre Ivo. Also, we can, in the meantime, load the second presentation while I will introduce the speaker. Okay, Andre is currently a PhD student, and he has already a master's degree in space engineering and technology from the National Institute for Space Research, INPE. He has an MBA in project management, and he also has a degree in computer engineering from Vale do Paraíba University. He already has a large experience in private high-tech companies, especially as software engineer, and also as system manager, coordinator, and system engineer. Since 2016, he has been a full technology specialist federal civil servant at CEMADEN, where he is responsible for the observational network and is conducting research and development of new technologies with the focus on forecasting and monitoring natural disasters. The title of the talk is on the use of ontology-based integration architecture in CEMADEN Natural Disaster Observational Network, and this is a collaborative work from Andre, Sheila Granado, Fatima Mattiello Francisco, and Rogerio Shibashi. I think we can start the YouTube now, the channel.
Hello everyone, thank you for the audience. My name is André Ivo and I'm system engineer at CEMADEN and PhD student at INPE. CEMADEN is the National Center for the Monitoring and Early Warning of the Natural Disaster from Brazil. Today I will talk about the use of the ontology-based integration in the CEMADEN network. So, in Brazil, most natural disasters are triggered by heavy or scarcity rainfall. The main events are mass movements, flash floods, wind gusts, crop collapse, burn. So, between 2007 and 2011, the natural disaster occurrences were increased, reaching an annual recurrence of the catastrophic events never recorded before. In 2007, the life of the 2.7 million people were socially affected. With the mission of the monitor and issuing alerts of the natural threats in mapping risk areas of the Brazilian municipalities, in July 2011, with the edition of Brazilian Presidential Decree, created the CEMADEM. CEMADEM operates the full-time monitoring the 958 municipalities classified as vulnerable of the natural disasters. To help this mission, CEMADEM has an observational network composed of the more than 5,000 devices for environment monitoring, like rainfall, humidity, temperature, river level, among others, installed in the risky areas. So, in this image, we see the example of the three devices from the CEMADEM. The first is the automatic rain gauge station, which is basically composed of the data logger, power system, transmission system, and rainfall sensor. The second is a hydrological station, which is composed of the data logger, power system, transmission system, rainfall, and radar to river level. This device is used for a flash flood and a flood, for example. The third is the semi-arid station. Like the other, is composed of the data logger, power system, transmission system, rainfall sensor, and soil humidity sensors. This station is used for the severe droughts in the specific regions. CEMADEM network is considered one of the largest national network of the data collection platforms, DCPs. However, it is still insufficient to monitor over 50,000 risky areas. That is, one device for every 10 areas. On the map, we can see that there are many uncovered areas and greater cover in the coastal regions that bring together a larger population density. However, monitoring must also be made interior areas, which also suffers from the disasters. For better coverage of the national territory, CEMADEM also uses network from partners, such as the National Institute for Research, WIMP, Department of Air Space Control, DSEA, National Water Agency, ANA, Geological Survey of Brazil, CPRM. These partners have devices for monitoring environment that contribute to CEMADEM. However, these devices have a specific purpose and must satisfy the partners' missions. Integration with the CEMADEMs becomes secondary and suffer difficulty in this process. Mainly due the integration of this partner's device, CEMADEM's network is not a monolithic system or with a fixed and well-defined dimensions, but rather a question of the integration heterogeneous system in a coordinated manner to solve specific objectives, which makes the network a system with a dynamic size and contours over time. This figure shows the CONOPS of the CEMADEM network. Basically, the devices installed in the risky areas transmit the data collected through the cell phones network. The data is written on the CEMADEM's FTP server, which is later processed to generate alerts to SENAD that trigger civil defense to protect the life of the civilization. The partner system integration, heterogeneous systems, is based on syntactic rules. Integration syntax refers to rule set that regulate the information composition that will be exchanged between systems. It's observed that in this integration model, any change and syntactic rules can break the entire process, leading to failure. In Semaden's syntactic integration architecture, syntactic rules are applied in the form of the standardized text files. For example, for these text files, rules are defined to identify the position of each relevant information to the integration process. The partner system writing the data files on the Semaden FTP servers follow the defined syntactic rules. The Semaden system reads the files based on the same syntactic rules and then records the information in the database. This process makes evident the strong coupling and the dependence between the systems, increasing their fragility and lowering the dependability parameters. The composition of the Semaden network is strongly based on a heterogeneous system, with the operational independence and not designed to operate together. In this context, the semantic conflicts may occur. Semantic conflicts occur when the system uses different meanings for the same elements. They appear to have the same meaning but do not. To reduce dependence and coupling between the constructed system, besides the overcoming the system heterogeneity, the use of the integration and the semantic level of the information is proposed. The use of ontology throughout the development life cycle allows the creation of the shared knowledge from the early stages of the cycle, reducing the cognitive efforts to understand and project among the stakeholders. The integration of the heterogeneous system flows through the integration mediate component. The integration mediator's main objective is to translate the communication based on the semantic mapping presented by the integration model and artifact produced in the analysis phase of the life cycle. So, in the syntactic architectures, to obtain the meaning, it is necessary to know the syntactic rules used to interpret the data. That is, the data carries information in addition the business rules. In the semantic architecture, depending on the user protocol, can separate the message into a key value pair, KVP, and from the key obtain the semantic mapping without efforts to interpret the data. An KVP is a set of the two linked data items, a key, which is a unique identifier for the same data item, and the value, which is the identified data. As the business rules are not incorporated in the data, the semantic integration architecture brings more freedom and promotes a weak coupling of the system, favoring the grow-up of the system dependability. So, the Cigarra project is a broad concept that can create a new Semaden network management and operation model, based mainly on the management authority decentralization under DCPs that make up the network. Cigarra uses several modern system engineering techniques, and the ontology-based integration represents just one of the techniques. The figures represent the high-level implementation of the Cigarra project ontology-based integration architecture. Basically, through a Java implementation of the semantic integration mediator, messages are consumed from the Cloud IMQ process, then go through the data semantic validation and are finally recorded in the database. The first step of the ontology-based integration specification process is to obtain the reference ontology from the legacy system. In this is an important step to identify the integration point and to know what will be the semantic equivalence address by the system. After discovering the new ontology for integration, a table for equivalence will be created, like a dictionary of terms. This process is called semantic mapping. In this way, the semantic mapping process is an important artifact to guarantee adherence to the new architecture and will be as a fundamental requirement to the semantic integration mediate component. And this table shows the DCP semantic mapping, which represents only one architecture and artifact fragment. In addition to that, the mapping process is interactive and incremental, where the specification must be refined until the level of detail is sufficient for development. So, for example, when receiving the information transmission data timing, the system will translate this information to send data time type to data time, and so on. So, it is important to note that this is just an example of equivalence. Ontology must be understood as a dictionary that can contain several terms for the same meaning. So, the dynamism of the social vulnerability imposes a great challenge to the mission of the CEMADEN, making it essential to maintain and expand its observational network to help preserving human lives. As presented in this work, the current structure of the CEMADEN's network is based on syntactic rules that generate a strong coupling between its constituent system, make it difficult for expansion and maintenance. With a new structure based on the semantic integration of the constituent system, the observational network architecture becomes more flexible and make the coupling weaker. The weak coupling then enable a safer and failure-free inclusion of the new device, also allow the evolution of the partner system with reduced collateral effects on the integration process. The new architecture proposed in the Cigarra project demonstrates how the semantic integration process can help mitigate difficulties and increase system dependability, improve the fault tolerance mechanism, which can make the system even more resilient. Finally, the use of the ontology in the semantic integration process improves the development of the shared knowledge, which can reduce the cognitive efforts to understand the project among the stakeholders. So, I think that's all. Thank you very much for the audience. I see you.
Okay, thank you also, Andre. Maybe if you can put on the video, it's Andre, if you can switch on the video, maybe it's nicer. Anyway, I will start asking if there are questions. First of all, any question for Andre? Okay, I have, in any case, one question, which is, we are talking about the integration of different constituent systems, which constituent systems, by essentially definition, are somehow have some degree of autonomy. And my question is, how much can you constrain on this constituent system? Can you believe they will not change their API, their interface, or the rate at which they are sending information to you? So which assumption you can put on these systems you are collecting data from? Okay, I'm afraid we have a communication problem.
Hi, Andrea.
Oh, fine. Okay, now I can hear Rogerio, I can hear.
Yeah,
Andrea?
I think Andrea is online. Andrea,
Okay.
can you hear? Can you respond?
I can hear Rogerio very well, but Andrea, no.
I think Andrea is responding. So, Andrea, I think I can try to respond. Today, we don't have sensors or data loggers ready to use using this ontology-based integration. So I think here in Semaden, we are making these integrations using the programming. We have to program our data logger to use this KVP pairs of keys to make this integration, because we don't have sensors or data loggers ready to use
Okay.
with this technology.
But my question was more, what do you expect from the systems from which you are collecting data? So can you somehow say that they will behave in a certain way, or they could possibly, for example, be updated and start communicating in a different way?
Sorry, what do we expect with the R's or sensors, or
yes,
for the industry?
Yes, from the sensors from you, and from the slides I understood you plan also to get in the future data from other sensors or other institutes as well. So
today we have a big challenge in Semaden with our observational network. First of all, it's because our sensors or our DCPs, data collecting platforms, are very, very expensive for us. Mainly because the dollars for us is very expensive, and the industry of these sensors or data loggers mainly comes from US or Europe. So we have to import the main part of the sensors and data loggers. So this is the first big challenge for us. The second challenge is how can we maintain these networks running? Okay, because we have a big country here. Brazil is too big, and we have to maintain this network along Brazil. And so we have another big cost to maintain this network, because we have to send some people, for example, from here at São José dos Campos to Manaus in Amazonia to make maintenance in this network. And another challenge that we have is because every time you have to make some some maintenance, we have to change some sensors because every year we have new sensors, and we have to change the sensors. And every time we have to make this maintenance, we have to do some changes in our software to integrate the sensors.
Okay, great. Unfortunately, Andrea, I see you appearing as speaking, but we don't hear. So the icon is like you are speaking, but we don't hear actually. Don't worry. Luckily, we have Rogerio, which can also maybe try to answer the question from Tommaso, which I will read the question. Which I will read the question. Essentially, it is if you are able to understand possible misbehaviors of the different sensors by monitoring the data that you're acquiring. For example, if you have any error detector, failure predictor, that can detect something is going wrong from the sensor side. So from the data you acquired, are you able to detect something is going bad?
And I think the question from Tommaso is to Lucas, or no?
No, it's to you. No, the question is, you are acquiring data from sensors. Are you doing any processing for example, error detection of possible data that got corrupted or got late or
no, it's not in component. Maybe in the future we are going to make some sensors, but now we are working just in data loggers to make this integration. So to detect any errors from the sensors, we have to detect in the KVP implementation in the data loggers. But maybe in the future we are thinking, we are talking with some partners from universities to start to develop some sensors and then in the sensors we can embed some softwares to make this verification before sending the data to data loggers.
Okay, thank you. I don't know if there are any more questions. I will hold until 3 for last questions. 3, 2, 1. No. Okay. At this point, we thank Andrea and also Rogerio for the talk and for the question and answer session. So thank the speaker again.
Thank you. Thank everyone. Thank you, Andrea.
And I think we can move to the third speaker. Thank you, Andres. So I'm sorry it didn't work, but this can happen with virtual conferences. Don't worry. The third speaker is Enrico Schiavone from another company, Resitec. I will tell you some in short biographic note. First, I know Enrico since when he started his PhD in Florence, which was when it was more or less 2015.
Yes, correct. Okay.
After PhD, he moved to Resitec. I don't really need to read your bio. I can more or less tell them.
Yes.
But now he works at Resitec. He works in research and is both a researcher and a project leader at Resitec. He's involved and also leading European projects as well as national projects all around the fields of dependability and security, and especially cybersecurity. He did the PhD in Florence. I was his co-supervisor, and I think also of the master I was your co-supervisor, right? But after
Yes,
Firenze,
hi.
did many interesting things in Resitec, and I think now he will tell us some of them. And he speaks Portuguese because he has been in Brazil several months for secondments during his research period. I think we can start the video now.
Welcome to this talk. I am Enrico Schiavone from Resitec, and this talk is about ResibBlockly, a model-driven engineering tool for security risk assessment of enterprises. This is the outline of the presentation. I will go through introduction and motivation, related work, and in particular the Amadeus project and the tool Blockly for System of System. Then I will describe how we evolved Blockly for SOS towards ResibBlockly, and in particular general improvements and the introduction of features as profiling and modeling. Then I will describe how ResibBlockly can be used for threat modeling and security risk assessment. Finally, I will conclude with conclusions and outlining the ongoing and future works. So, cybersecurity is a key concern for the large majority of medium and small-medium enterprises. For many reasons, one of which is the COVID-19 pandemic, which forced many businesses to quickly implement remote working, often without having put in place adequate defenses. Then, the Industry 4.0 revolution and the convergence of IT and OT, which exposed to interconnected security and safety risks. And often the impact of attacks is extremely negative, especially in economic terms, like ransom to be paid, blockage of the production, and damage to the reputation, and so on. So, for those reasons, cybersecurity risk assessment is an activity that enterprises should put on top of their priorities. What is the state of the art and the challenge of this topic? So, currently, various tools exist for supporting cybersecurity analysis. For instance, threat modeling tools, some of which also support the security risk assessment. However, when the system under analysis is large in scale and highly interconnected, the cognitive complexity required for modeling and analyzing it with state-of-the-art tools makes the activity hard or even inconvenient. So, in the past, my company Resitec participated in an Amadeus project, which acronym means Architecture for Multi-Criticality, Agile, Dependable, and Evolutionary Open System of Systems, a European project that has been concluded in 2016. Which were the motivation and challenges addressed and faced by this project? First of all, to reduce the cost of modeling large and complex system of systems. Then, to reduce the time for training. To manage and query large models. To simulate the modeled system. And to reduce the time for early prototyping. So, these challenges has been won thanks to some means, some keys. In particular, they are the reduction of cognitive complexity, the continuous model validation, different model viewpoints, the embedded behavior, the automatic code generation, and an ad hoc domain-specific profile for the domain of system of systems. So, Amadeus studied the literature about the system of system basic concepts. These concepts have been represented in high-level representation, so ontologies that connected this concept have been provided. This high-level representation has been also semi-formalized in different viewpoints. This brought to the Amadeus system of system SysML profile, where viewpoints have been modeled in this language, organized in a single profile which is composed of viewpoint-related packages and sub-packages, like the structure, dependability, multi-criticality, security, time, dynamicity, evolution, emergence, and so on. Thanks to the Amadeus system of system SysML profile, and with the usage of the Google Blockly library, which is a JavaScript library for building visual programming editors, the tool Blockly for System on System was developed. What is the usage of this tool? So basically, there are two users involved. One is called designer, which is not required to have knowledge of SysML or UML, but only high-level knowledge of system on system and of the tool itself, because previously the assumption is that another user, the system on system expert, had provided the profile which is included in the tool. By doing so, the system on system designer, so the end user, by leveraging this Blockly for SOS tool, can perform some activities like modeling, validation, code generation, simulation, collection of result, and analysis of result. Moreover, the model can be exported in different formats like PlantUML, XML, and the code can be generated in Python language. One of the main characteristics of Blockly for SOS is the continuous validation. So on the left we can see the viewpoints once they have been integrated in the tool, and in each viewpoint there are several related blocks. These blocks can be used for modeling through drag and drop or by selecting them through drop-down menu. And the continuous validation is obtained because only compatible blocks can be connected. This is an example of a UML model of a medium-sized smart grid, and this instead is the corresponding model in Blockly for SOS tool. So we can notice the reduction of cognitive complexity. Now let's go to ResiliBlockly. So how the Blockly for SOS tool has been evolved. First of all, we went through some general improvements to the software. So the software modularity has been improved in order to abandon a monolithic architecture. We improved the software maintainability thanks to the decoupling of front-end layer from the back-end layer, and it is now much more developer independent. We improved software reliability because the main algorithms are now developed in Java, and this allows a fast and easy extensibility and maintainability of the core software features. Moreover, we improved software extensibility because now the layout adapts automatically to different resolutions and devices. Finally, we also improved software validation, and now the code obtained is more testable. Another important difference introduced by ResiliBlockly is the distinction of profiling and modeling. So we have two main concepts: the profile, that is a meta model, which is an abstraction of components and relations for a specific domain, while the model is the instance of a meta model, so the instance of a profile once instantiated. So this table summarizes some of the difference between this tool ResiliBlockly and its father, Blockly for SOS. So the main difference is that in ResiliBlockly not only the model is defined by the user, but also the meta model, the profile, can be designed within the tool. Of course, we expect this meta modeling to be an activity performed by more expert user, but in general, several profiles can be realized within the tool now, while for Blockly for SOS this one was an activity that was not modifiable and executed once by the tool developers. So this is an overview of the new workflow, of the new set of activities that can be performed with ResiliBlockly. We still have a profile expert, which is in charge of creating a custom profile, but as I said a few moments ago, this profiling activity can be performed within the tool and as much times as needed. Once the profile is validated, the modeling activity can be performed. It is thought to be performed by a designer, but in principle, these two users can be also the same user. The modeling can go through, as always, as in the previous version, validation, code generation, simulation, collection of results, and analysis of results. But moreover, an important introduction in this version, so in ResildBlockly, is the threat modeling, which leverages existing catalogs, the CWE, the CV, and the CAPEC catalogs. Once the threats have been identified and associated to the model elements, a risk assessment can be conducted. Moreover, the interoperability of the tool, so the possibility to import and export to the tool and from the tool, has been improved. So the profile can be exported or imported to or from other tool, as well as the model, which can be imported or exported as well in a core XML format. And moreover, the code generation functionality will be integrated with the external development environment. So this is an overview of the two main features of ResildBlockly, which are the profile designer and the model designer. So let's start from the description of the profiling activity. This is an overview of the profile designer, where we can see on the left a block palette, where the user can basically select between these elements the necessary blocks to be used for realizing a profile. So there are classes which embeds attributes and relations. There are attributes, there are relations that can be of different type, like reference, composition, and so on. And also the cardinality of the relations can be specified. And then there are menus that are basically collections of blocks in the profile, which are composed of menu items. Each menu item represents a block in the profile. Another important mechanism that is available in the profiling is the inheritance. So a class can inherit from another class in the profile attributes and then extend them with additional ones. Then on top we have a menu for the import and export of the profile, the search of blocks, a toolbar with some features that I will explain in the continuing of the presentation, and lenses for zooming in and zooming out. This is an example of a profile where we have a menu that is called architecture, composed of different menu items, and an example of two classes, the system of system and the constituent system. So this is basically the Amadeus system of system profile, which has been recreated in the new version of the tool. Then let's go to the modeling feature, so the model designer, which embeds this feature. This is an overview of the model designer. This is the interface when the user can select a profile and create a completely new model from scratch, or otherwise can open a new model or import an existing one. This is an example of a model which has been realized with the Amadeus system of system profile. This model is very simple because it's composed of only two elements: a smart grid ecosystem, which instantiates the system of system class, and the gateway, which instantiates the constituent system class. On the left, we can see the set of menus that we have specified in the profile. Instead, on the right, we can see the graph corresponding to the real model that we have on the left, realized with the Blockly library, so with the Blockly blocks. So this is a corresponding representation that can be used also for navigating the model. This, of course, is a very simple model, but more complex ones can be also realized within the tool. And this is an example of a complete smart grid ecosystem. So again, on the left we have the Blockly representation, and on the right the corresponding graph. So let's go to the threat modeling and risk assessment. So in the profile designer, an activity that can be conducted is the preliminary specification of weaknesses and vulnerabilities. So in other words, the user is asked to select one of the blocks in the profile. Basically this selection is from this drop-down menu, and then in the weaknesses tab the user can add some weaknesses that can be pertaining to different catalogs, or can also be custom weaknesses that are personally defined and customly defined by the user. So this is an example of search and specification of weaknesses that come from the CWE catalog, so the catalog of common weaknesses of the Mitre Corporation. So for instance, the user is able to type a keyword in the search bar, like for instance here API, obtains a set of weaknesses that are found in the catalog starting from this keyword, like in this example we have 9 results, and can, pressing on the plus blue button on the right, can associate these weaknesses to the selected block. So in other words, this means that the block is considered an asset, and this weakness is a threat that is identified and associated to the asset. Several weaknesses can be associated. The user can also jump to the catalog to understand more in detail the specific weakness, and when it's satisfied can confirm the association. This operation, of course, can be repeated for all the blocks that are considered asset and are under analysis. Similarly, so this is the result that is obtained in the main window after the association of a couple of weaknesses. Similarly, weaknesses can be also associated, but starting from a different catalog, which is the CAPEX, so the catalog of common attack patterns of Mitre. So with a similar approach, by using keywords in the search bar, the user can look for attack patterns. Like in this example, we typed DOS, denial of service. We obtain 5 attack patterns that can be inspected. Again, by pressing on the CAPEC logo, the user is able to jump to the catalog to understand more in detail the attack pattern, and to finally identify weaknesses that are related to this attack pattern and that can be potentially existing in the system, and in particular associated to the asset. The association is performed again by pressing this blue button, and then when the user is satisfied can confirm the association. With the extremely similar approach, also vulnerabilities from the common vulnerabilities catalog of Mitre can be associated to the blocks of the profile. So in this example we selected the constituent system block, and we associated one vulnerability that is this one represented here. Again, also here, custom vulnerabilities can be defined and associated by the user. So this concludes the part of preliminary specification of weaknesses. This means that once this profile with some weaknesses and some vulnerabilities is instantiated in a model, those weaknesses and vulnerabilities will be inherited in the model. So the final user will automatically obtain, when instantiating a class in a model, the weaknesses and vulnerabilities that have been previously associated to that element by the expert user in the profile designer. But this specification of weaknesses and vulnerabilities can continue also in the model designer, when the specific elements and the typical components are for sure clearer than in the abstract meta model. The specification of weakness is basically the same also in the model designer, but an additional important result that we have here is the representation of attack tree or attack graph, as in the one that you have represented here. So basically, the user, by clicking on a weakness on the attack tree button, obtains this diagram, where on top, on the root of this tree, there is the selected weakness, and the related attack patterns are directly connected with it, if available in the catalogs. Moreover, any preceding attack pattern is also displayed, and the related weaknesses of these attack patterns are also available and seeable. So why this representation is useful? Because if I associated the weakness to my asset, to an element of my infrastructure, of my system, I can understand which are the related attack patterns, and moreover, which are the related weaknesses that I may need to take care of in order to enable an attacker to perform these attack patterns. So it's a kind of functionality that allows the further analyzing of the weaknesses. Then another activity that can be performed is the visualization of a weaknesses report. So by pressing on this button, show weaknesses report, the result obtained is the following. We have a set of weaknesses, some of which are inherited from the profile, that can be excluded by the modeler, and then there are some other weaknesses that can be instead maintained, still inherited from the profile, and finally some other weaknesses that are instead available because associated by the final user in the model. So this weaknesses report can be exported as a CSV file. This is the specification of vulnerabilities in the model designer. Say this is similar to what is contained in the profile designer. This is an overview of the research of SQL keyword and an overview of the obtained result from the CV catalog. Finally, another functionality that is currently available in the model designer is the assessment of risk for weaknesses and vulnerabilities. So basically, in the risk tab of the model designer, in particular on the weaknesses inner tab, the user obtains a set of parameters that are the common consequences and likelihood of exploit, which are two fields that are populated in case of these parameters are available in the CWE catalog. So the information from the catalog is automatically displayed here in case it exists. Then there are three important inputs that are asked to the user, which are the severity, which must be a value in the 0-10 interval, and then the likelihood, which can be selected from a drop-down menu and is to be expressed in qualitative values, while the corresponding risk is obtained from the application of the NIST Special Publication 830 Risk Assessment Matrix. The default value for the severity is 10, and the quantitative values are translated in the corresponding qualitative ones. So this is the matrix that I was mentioning, that is retrieved from the NIST 830, and thanks to which, basically using the two inputs, severity and likelihood, the final risk can be obtained. With a similar approach, also the risk assessment of vulnerabilities can be performed, but with the main difference. So the vulnerabilities, in some cases, report in the NVD catalog a base score that is computed with the CVSS, so the scoring system. So in the case of this base score being available, the tool automatically presents this base score here in the severity field. Otherwise, if this value is not available, the user is asked to provide the severity again in the range of 0-10. Another important information that the user needs to provide is the version of the CVSS that he or she is interested in retrieving from the NVD catalog. Then the assessment continues again with the likelihood selected from the drop-down menu in qualitative values, and the risk is again computed by the application of the same metrics. So, to conclude, ResiliBlockly is a tool for the modeling of very complex systems and infrastructure, but this modeling is obtained with a reduced cognitive complexity. Moreover, is a tool for modeling and identification of threats, and for the risk assessment of the identified weaknesses and vulnerabilities. Which are the ongoing and future developments? Many of them are planned. So the first one is the introduction in the Profile Designer of the identification of functions and interfaces, because this feature will allow the modeler, so in the Modal Designer, the performance of HAZOP analysis, and in particular functional and interfaces analysis. Moreover, by introducing the preliminary specification of dependencies in the Profile Designer, the modeler will be able to analyze the risk of cascading effect. And additional developments that are ongoing are the integration with the mood standard in the Model Designer, as well as the modeling of functional requirements and automatic generation of test cases, the FMEA, so the failure modes and effect analysis, the generation of source code from the model, and the simulation of behavior of interconnected components, especially when under the attack. So this concludes the presentation, and thank you for following.
Okay, great. Thank you, Enrico. We thank the speaker, and we also start with the questions. I think there is already a question in the chat from Mirko, which is related to the list of attacks from weaknesses from CWE. Mirko is asking if it's just a slice of the vulnerabilities or the full list. And I would also add, if it is the full list, what is the dimension of this list? Is it something that you can manage, or does it require some filtering or some special trick?
So in principle, can you hear me, Andrea?
Yes, very well.
Okay, in principle, all the weaknesses in the catalog can be associated to any block. So if it makes sense, you can associate, I don't know, hundreds of weaknesses to the same element of the model. Of course, this may not have so much sense. So in order to have an association that is useful, I think that you have to find an approach for selecting which weaknesses are relevant for the block. In the tool, we implemented the keyword-based search, but you can try to use a different approach. For instance, you can use the different domains that are available in the catalog, do the search externally from the tool, and then look directly for the CWE ID or CV ID and associate and retrieve the weakness by searching the ID and associate it. So there are different approaches that you can adopt. One is embedded in the tool, that is the keyword-based search.
Okay, clear. Are there any other questions? In the meantime, I will do my two questions, which are actually very close to the one I made to the first speaker, which are to Lucas, which are, how does this relate to standards, especially security standards, I suppose, or safety standards? And what do you expect from the customer? Do you expect he has the competence to use this, or are you using the tool and then giving it to the results? What is your position here?
Okay, so regarding the standard, the tool currently do not mention any standard explicitly. Anyway, CWE and CV are often mentioned in some security standards. So something that can be considered is trying to follow a security standard and then model a system and analyze the system with the tool, having in mind the requirements of the standard. This is something that currently is not supported by the tool, but in the future we can think about this. So I mean, in the profile, maybe the profile designer can also select which is the standard that he or she is interested in, and tune the following assessments by following the standard. For instance, the risk matrix can be the one indicated by the standard, and some other modifications can be considered in this from this point of view. And regarding the customer, so the idea is that the profile is realized by some expert user, and we can be as the company that realizes the tool and maybe offers some consultant service with the tool. We can be the ones that realize the profile, while the final user, the modeler, can be the user that instantiates the profile, realizing their own infrastructure model or their own product model, instantiating the profile realized by us. This is currently the idea, but in principle, the final customer can just I don't know, describe how the company's the infrastructure of the company is done, is constructed, and we on our side do everything. So profiling, modeling, risk assessment, and provide them the final result. This is also another option.
Okay, quite clear, later clear also. Are there any more questions? What is the experience level required to create the profile? This appeared from Mirko in the chat.
Hi, Mirko. So any kind of profile can be realized. Imagine that you are realizing a meta model of a new ML. More or less, this is the same level of experience required. So you have classes, relations, attributes. It's not hard to realize a profile. Of course, it's like I don't know, a tool with which you can do everything. So realizing an important profile that then you can use for realizing a model that makes sense is not so easy because it requires time. But in general, realizing a profile is quite easy.
Okay. Thank you. Thanks, Enrico. Okay, are there any more questions for Enrico? 3, 2, 1. Okay. No, so we really thank also Enrico. Thank you for your
Thanks
time.
to you all.
For your talk. And we close the speaker with the final. We close the session with the final thanks to the 3 speakers, my co-chair Rogerio, also the organizers and all the participants. Thank you for attending, and LAD will continue after the break with more sessions.
Yeah, thank you for organizing this session, Andrea.
Thanks to you. Thanks.
Thank you, Andrea. Thank you all.
Thank you. Bye. Bye.
Bye-bye.
Thank you to everyone. Bye-bye. Thank you, Andrea.
Thanks.